All right, so this is just going over some additional examples of 6.3 adding and subtracting after number 4. But if you have any questions on those, just let me know. I will post the key probably Wednesday, early morning, so you can check it. But it's okay if you submit it before. That's also fine. So let's just start on 5. So one thing that I do is I put each denominator, if it is a multi-term part, I just put it into parentheses like that so that I am very specific on what exactly is in my denominator. So, just like if we're working with numbers, the easiest way is to just multiply them by each other, and then we'll have the same denominator. So, right, so multiplication is kind of the only way that we can change fractions, because we're technically multiplying it by 1, because p plus 5 over p plus 5 is 1. That's why what we do to the bottom we have to do to the top. So just a reminder of the rules there. So I just multiply them by each other, and then I have the same denominator. So I have 4p squared times p plus 5. And then the top, I'm going to have 28p squared, because 4 times 7 is 28. And then I'm going to have plus, and I got to be careful, because if it is subtraction, I'm going to have to distribute a negative 3, but this is positive 3. So I have positive 3p, and then positive 3 times positive 5 is positive 15. All right, and I'm not going to multiply the denominator because I do want to kind of think if there's anything that will simplify here. And so because I have a trinomial there, I'm going to have to do my a times my my a times my c. So 28 times 15, and that's 420. So if we look at our signs and we try to think what adds to give us 420, multiplies to give us 420, but adds to give us 3, because 420 is positive and 3 is positive, there's no way we could get there. So I know that I can't factor that, and so I know that I can't simplify it. So that's what I was trying to do, just see if I could simplify it. But I cannot. And that's why I didn't multiply the denominator, because I would like to see if I could simplify it. At this point now I can multiply it. I don't think I did on the key. I just left it there. But just real quick, we got our denominator the same, just kind of going back over this. We added our numerators, and then we kept our denominator. So you don't have to do this last step, but I'm going to do it. All right, so I suggest you pause, try 6, see how it goes, and then play this. All right, so again, I like to put these in parentheses just to kind of help me see what the denominator is that I already have. So if I multiply this by x minus 3, I have to multiply the top by x minus 3. And then I'm going to multiply this by 5x plus 5, and this by 5x plus 5. Okay, so my numerator, notice my denominator is the exact same, so I'm good to go now. Now I can combine my numerators, and I'm going to have to be careful because it's negative. Remember, we have to distribute it to all parts. And then on the bottom, I'm going to have 5x plus 5 times x minus 3. Now, on most things, we will simplify as much as we can, but as far as this one goes, there's not going to be too much we can do. So I'm going to distribute this, and I'll get 25x squared plus 25x, and then I'll distribute that and get x squared minus 3x minus x plus 3, which will give me, sorry, I'm running out of room, but I'm not going to write the signs, x squared minus 4x, and then a 3. And notice I'm subtracting all the parts following that subtraction sign. So negative, positive, negative. Okay, then I'm going to combine like terms here. So I'm going to get 24x squared plus 29x minus 3 divided by, and I'm just going to leave this because if we can factor the numerator, it might cancel out. So I don't want to multiply that, okay? All right, so I'm going to check this guy. And I'm gonna see my A times my A times my C, so negative 3 times 24 gives me negative 72. So I want to see if there's anything that multiplies to give me negative 72, but adds to give me 29. So I'll just kind of make a quick list here. So I have negative 9 times 8, negative 8 times 9, and then I'm going to check a few more numbers, see if they work. And then I have negative 12 times 6, negative 6 times 12, so none of these are adding up to 29, obviously. Let's try dividing it by something a little bit bigger. So I have negative 2 times 36, which obviously doesn't give me 29. So I don't think this is going to work, because the closest I can get is negative 3 times 24. So, I mean, like, it's going to be something in between there. So I can't factor that, so nothing's going to cancel out, so I am done. All right. So let's do another one. And like I said, but if you're good, you're good. You don't need to continue watching this. Okay, so on this one, 7, I'm going to simplify this fraction first. We learned how to do that in the last 2 sections of this unit. And then I am going to factor this. Okay, and so really the best thing that you're going to do is just multiply these things by each other. So I'm going to multiply this by 3k minus 7. And so originally I had the k, now I have a 3k minus 7. And then I multiplied this guy over here by just k. So originally on the left, all I had was k. Originally on the right, all I had was the 3k minus 7. So then I just multiply what I multiplied on the bottom to the top. I don't want to cancel anything out because my denominators have to be the same. So I have 3, I'm going to just rearrange it, 3k times k minus 7. And then on the top, I'm going to have 3k minus 21 times 1 stays the same, minus 5k, which is going to give me negative 2k when I combine like terms, minus 21 over 3k times k minus 7. And then the numerator doesn't have any like terms, so I kept the denominator so I could potentially simplify it, but the numerator's not working with it, so we're done. All right, 8. Similar idea here is the 7s will cancel out, leaving me a 1 up here. And so I'm going to need an extra m, and then I'm going to need an m plus 2. So that's going to be m squared, and then that will be m plus 2. So I have m plus 2, so don't forget that m hanging out there. Okay. All right, so in the numerator I have 5m squared plus m plus a positive 2, which is just plus 2, over m times m plus 2. Okay, and then I can quickly see that I'm not going to be able to factor the top because my a is 5 and my c is 2. 5 times 2 is 10, and the only things that add to give me 10, there's nothing that's going to, the multiples of 10 are not going to add to give me 1, right? So no way that's going to happen. So I can't factor it, so I'm done. All right, 9. Oh, we're so close on that first fraction, but so far away, really. Okay, so I'm going to multiply this by x plus 6, which means I need to multiply this by x plus 6. And then I need an x plus 2. So, it's just the same as when we're working with normal numbers, right? You got to make sure that they have the same denominator. Once they have, so this is more just tedious than anything else, right? So we have the same denominator now. We multiplied that through to get it. And now the top is going to be kind of nasty. And I already did multiply this all out. So I multiplied these guys, right? Then I multiply those guys, and then I combine like terms. And in the end, like things are going to cancel out pretty nice, but I'm only going to get 3x plus 30. And so multiply those out, combine like terms. And I can factor that negative 3x plus 30, but it'll just be x minus 10, which is nothing on the denominator. So I'm not going to rewrite that in factored form because it won't do any good. All right. So if you need me to do, let's just do 10 since it's right there, right? So 10, the denominator is 1, if you don't see it, right? And so, I mean, I'm just going to multiply 1 by that stuff that we have on the left. But what we do to the bottom, we have to do the top. And the reason it works is because we're technically multiplying negative 4 by 1, right? Because those would cancel out. But we're not going to. Yep, you're so good. You're good.
Pull up a chair.